Okay, today's objective is going to be solving systems of linear inequalities. So this is going to be the final, I would say, notes before we start getting ready for our Chapter 4 test that's going to be in the next upcoming days. So we are wrapping up Chapter 4 after this. So everything we've talked about was solving systems of equations. This last section is going to be on solving systems of linear inequalities. So a system of linear inequalities is a set of two or more linear inequalities in the same variables. An example is shown below. So the only difference between a system of inequalities and equations is that instead of an equal sign, there are inequality symbols. A solution of a system of linear inequalities in two variables is an ordered pair that is a solution of each inequality symbol. So what does this mean? Tell whether each ordered pair is a solution of the system. All you have to do is remember it's x comma y, plug in 3 for x, plug in 5 for y, but you have to do it for both to see if it's true. So we have to do it for the first one. It's a little tedious, I understand. If 5 is less than 2 times 3, 5 is less than 6, that's true. You have to do it for the second one. You have 5 is greater than or equal to 3 plus 1. 5 is greater than or equal to 4. That is also true. So that means 3 comma 5 is a solution of the system. Now let's do the other one. We have negative 2 comma 0 as well. So if 0 is less than 2 times negative 2, 0 is less than negative 4. That's not true. So if one of them isn't true, then the entire thing is false, right? So for it to be a solution, it has to be true for both. If it's not true for one of them, then it cannot be true for both, okay? So why don't you work on number 1 on your own? All right, next, graphing a system of linear inequalities. Step 1, here's how you graph it. You just graph each inequality in the same coordinate plane. So you pretend like there's nothing different between the two and you just graph them. Step 2 is find where they both intersect. Or not intersect, overlap. Find where they both overlap. This section is the graph of the system. So essentially you're kind of creating like a Venn diagram, but in inequality form, right? So let's do an example. So this is what it's going to look like. The blue graph, blue shaded, is the less than or equal to symbol. So that's why I shaded below, whereas the red one is above, and where it's shaded in between, this is going to be your solution of your inequality symbol. Okay. All right, so now let's do a couple examples together. I have y is less than or equal to 3. Let me graph that real quick. I'll do this in orange. Y is less than or equal to 3. Remember, less than equal to, that's a solid line at 3. And because it's less than or equal to, I'm going to shade below. Right? Remember that, I'll explain here. And then in this one, I'll do this in this blue color. I have y is greater than x plus 2. So I plot 1 at 2. Slope is 1. So up 1 over 1, up 1 over 1, up 1 over 1. So this is going to be my graph. But remember, this is going to be a dashed line. Why? Because it's a greater than. It does not have an equal to. And notice how this one is a greater than. So I'm going to shade above. So now all you have to do is figure out where they both overlap. And it looks like they actually overlap in this tiny section right here is where they are both blue and orange. So for it to be a solution set, they need to overlap right there. All right. All right, now let's do this one as well. I'll choose the same color for consistency. So let me graph this first one. Some of you may actually, you know what, I'm going to solve for y to make it easier for myself. I have y is less than negative 2x minus 1 minus 2x minus 2x. I have y is greater than negative 2x plus 3. Okay, so if I'm going to graph it, let me graph this in orange. So negative 2x minus 1, so it looks like it's going to be like this, right? But negative 2 is my slope. Whoops. So that means it goes like this. Negative 2, negative 2. So it should look like this. It is going to be a dashed line. All right, now let's do the other one. I have y is negative 2x plus 3. Here it is. Plus 3, negative 2x, negative 2x, negative 2, negative 2, negative 2, negative 2. Once again, it's a dashed inequality. Oh, I forgot to shade for my first one. Oops. So let's go. Actually, let's continue with this. Because it's greater than, I'm going to shade above. The other one is less than, so I'm going to shade below. Do they ever overlap? The answer is no. So this is going to be no solution. So if they do not overlap at all, it is going to be no solution. All right. All right. So now why don't you try numbers 2 and 3? It's a little difficult to see the feedback on it, but why don't you try these out? Actually, why don't you try these out and check your answer with the person next to you, if you guys are both at the same page. So now we're going to kind of work backwards here. We're writing a system of linear inequalities represented by the graph. So we're working backwards. Right, so now we're given this inequality system, and I have to come up with the inequalities that come with it. Let me come up with this one first. I think this one's a little easier because it's a vertical line. Right, it looks like it's a vertical line at 3, so it's going to be like x equals 3, x is something like x something 3. Right, so but take a look. Here's how you could tell if it's going to be less than, greater than, less than or equal to, greater than, equal to. Well, I also know it's going to be a less than or greater than. Why? Because it's dashed. Right, so remember, where is it shaded? It's shaded to the left of it, so that means the first inequality must be x is less than 3. If it was shaded to the right of it, it'd be x is greater than 3, but because it's shaded to the left of it, it is x is less than 3. So that's that first one. Now, let's do the other one as well. Looks like the y-intercept is 2, so it's going to be y is something 2. It's going to be greater than or less than. Why? Because once again, it's a dashed line. Looks like the slope is negative 1. So it's going to be y blank negative x plus 2. And once again, because it's shaded below, it must be y is less than negative x plus 2. So it looks like my two systems of inequalities is it's going to be x is less than 3 and y is less than negative x plus 2. This one may require a little guess and check, a little bit more thinking with regards to everything. So just be careful with these. So for this orange line, always identify your y-intercept first, and then you can work backwards and figure out what your slope is from there. And that should be helpful for you. If you have any questions, you can let me know on the next day. So with your group, if you're ready, why don't you try these next two right here. So I'll give you the points if it's hard for you to find the slopes between the points. Here's one point, here's another point, here's another point, here's another point, and use that to help you find the slopes and the y-intercept with these problems. All right, last but not least, the word problem. You have at most is going to be less than or equal to 8 hours to spend at the mall and at the beach. You want to spend at least is going to be greater than or equal to 2 hours at the mall and more, which is just greater than 4 hours at the beach. Write and graph a system that represents the situation. How much time could you spend at each location? Okay, so now let me define my variable. Let's say x is mall, y is beach. There's actually going to be 3 systems for this one. Whoops. So it looks like at most 8 hours. So it's going to be x plus y is less than or equal to 8. So that's my first inequality that I'm going to graph. And it also says I want to spend at least 2 hours at the mall. So x must be greater than or equal to 2. And more than 4 hours at the beach. So y must be greater than 4. Right? Because beach is y, x is mall. And then from here, let's graph everything that I know. So I could say this is mall, this is beach. X plus y is less than or equal to 8. That means both my x and y intercepts are 8. Right? So that means I just have to plot 8. Actually, let me do these in different colors. So I'll do this in this. 1, 2, 3, 4, 5, 6, 7, 8. And it's going to be a solid line. And remember, because it's less than, I'm going to shade below. Right? All right, and then next I'll do this one in this magenta-ish color. X is greater than or equal to 2. So that means it's going to be a solid line, like here, greater than or equal to 2. So that means everything, let me try that again. Everything's going to be on the right side of this. I know it can get a little messy here, but that's totally fine. And this last one, I'll do it in orange. Y is greater than 4. 1, 2, 3, 4. Y is greater than 4 is a horizontal line. So it looks like anything above this would work. And, well, so now all you have to do is find where all 3 overlap. And it looks like all 3 overlap at this little tiny triangle. Right, so that's going to be your solution for this example. So you can say, well, there's actually a bunch of different possibilities. Right, 1, 2, 3. You can say like 3 hours at the mall. If you do 3 hours at the mall, you would have to do 3 hours at the beach. You could also say like 2 hours at the mall. So you could essentially choose any point that's within here. You could choose this point. Oh, let me choose a different color so it's easier to see. You could choose this point. You can choose this point. You can choose this point. It really doesn't matter. Actually, hold on. I messed up. Hopefully some of you were able to catch my mistake. This actually should be a solid line. So if I do like 3 hours at the mall, I would have to do like 3.5 hours at the beach, right? Because I can't choose a y value that's on the line. So if it's 3 hours, then it would have to be like here. You could choose this point right here, this point. So there's actually an infinite number of solutions you can have. It does not matter as long as that is inside this triangle. All right? So that is it for today's lesson. Why don't you fill out your level of understanding? Go ahead and begin on your homework. It is a big ideas. We'll go over any homework questions on the following school day. Bye, everyone.